Okay, we're here at go-to-math.com. Let's click on the calculus button and go down to the disk method. Find the volume of the solid. Just click on that one there. Find the volume of the solid formed by revolving about the x-axis. What are we revolving? We're actually revolving f of x and g of x, really, kind of around this thing. I mean, technically not really. What's really happening here is we're summing up, it's all about the radius. I mean, that's really what it's all about. This thing about revolving, I mean, that's what it's turning out to be equal to anyway. Uh, anyway, well, this one here, so we just did a problem here, 1.1, and so you should be able to use some logic and figure out how to find this. Now, what this is we're taking this cross section and revolving it about the x-axis, I guess you want to say. Let me just go ahead and write this down, and then we'll head over to the whiteboard, or whatever you want to call it. I call it the whiteboard. Can't call it a chalkboard. Now, I would use a chalkboard, but I think a whiteboard just looks a lot cleaner. Plus, I get chalk dust everywhere. What are we doing? Okay, so there we go. Let's move over into the class. Everybody gather around. All right. Let me just go ahead and write these functions down here. So f of x is equal to 8. G of x is equal to something, 12. And then we're on this interval between 0 and 9. 0 and 9. All right. Okay, so I'm going to draw. Now, this is going to be on its side here because, I don't know, I just find it a whole lot easier to draw a picture when it's on its side. Woof, that one's kind of crazy. So if you can imagine a toilet roll, okay, we got an idea what this is. Anyway, so this is like a toilet roll, let's say, or a roll of paper towels or something. And the volume that we're finding, maybe I should use a different, I use blue for the shaded region. We'll shade this in blue here. How's that? Okay, so this is all blue. Blue, okay. And then the inside piece, we're not calculating the volume of the inside of the cylinder. We're just calculating all the blue area. And what we're going to end up doing is we're going to find really the area of the whole thing, or the volume, I'm saying, the volume of the entire cylinder, and we're going to subtract off the inside piece. We're going to subtract off the inside piece, okay? Now, let me go back. So if you can imagine, I'm going to draw a rectangle here. Okay, you see this right here? All right, would be the inside of the cylinder, or at least half of it. The other half would be down here. But this is the inside of the cylinder, and then this piece right here is actually the blue region, and of course we're going around in this direction. And what's actually looking like, I should have probably drawn it more to I should have drawn it more to what our picture looks like. Let me try to do that here. So it's actually the shell of it, or the outer end of it, is a lot thinner. Okay. Looking down, make sure I didn't pause the video again, start it up. Alright. So as you can see here, dotted line means we're looking through it. Okay, we're looking through it. Alright, this looks more like what our graph kind of looks like right here. Alright. So as you can see here, blue stuff indicating the cylinder there. Alright, so as you can see, it's a whole lot thinner than actually what this picture here looks like. So we're going to be finding uh, the big cylinder first and then subtracting off this piece. Okay, subtracting off this piece here. Alright, does that make sense? Okay. Alright. So let's go down here and kind of sketch back. So we're going from 0 to 9, and this up here is 12 and 8. All right. Okay. So if you can imagine, we're going to be revolving this part first, all right, up to 12. So let's just go ahead and set that up. So we're going from 0 to 9, and I always bring the pi outside. Now remember what this formula was in 1.1. It's pi, right? This is a function in here, squared and then dx. Okay? Alright. And in this case, r is actually the big number, but I want you to try to understand what's going on. Now, technically, they call this the washer method because the washer has a hole in it, but what we're really doing is the disk method. All right, two separate integrals of the disk method. Okay, so we take the outer one and then we subtract off the smaller one. All right, so we find this volume first. So this is our function here, 12 squared dx, and then we subtract off the smaller one, we're still going from 0 to 0 to 9. That's like the height of the cylinder. 0 to 9, this time it's 8 squared dx. 8 squared dx, okay? So you can actually just combine these together, and that's what I highly suggest, that you combine them together. So we have 12 squared minus 8 squared dx. Alright, just combine them together. And they call this the washer method, alright? But understand, we're really just doing the disk method on both of these. Okay, it should be understood. So pi, go ahead and take the integral now. So we have 12, or, uh, since, okay, we can just do that. 12 squared minus 8 squared x, right? Going from 0 to 9, okay? So we end up with pi times, what is this, 144 minus 64 times 9, and if we plug 0 in, we just get 0 out. Alright, so let's go ahead and see what that is anyway. 144 minus 64, and I get 80 times 9 is 720, right? Is 720, so I get 720 pi. 720 pi. Okay. Now you could just use geometry and figure this out, right? Volume of the big R, we could call it, is equal to pi times r. The radius is 12 squared, and the height is 9, right? And then volume of the little radius, pi times 8 squared times 9. But isn't that what we get here? Right? And then you'd say volume is equal to volume of the large radius minus volume of the small radius. So you see we end up with the same thing. Okay? Alright, 720 pi. I'll like scroll down the screen real slow, making sure that's it. All right, 720 pi, that's what we get. Okay. So come on by, practice that, check it out, and I'll see you later.